It has been 13 days. Let's go. Sorry. All right, I was starting to get goofy, guys. All right, today we're going to continue our discussion with with functions. Yesterday we talked about linear functions, and today we're going to talk about non-linear functions. So, with the smarty pants that I know that you all are, I can assume you guys know that this would mean that they do not make a line, because it does not have to make a straight line to be a function. As we talked about the other day, it just has to pass the vertical line test and have each input have one output, but that doesn't mean it makes a straight line. So there's two different types, linear and nonlinear. Today we're looking at nonlinear. As you guys can see here, nonlinear functions do not have a constant rate of change, and they do not make a straight line. I need to figure out where to put myself so you guys can see everything. All right, there we go. So as you guys see, the height of a juggling ball as you throw it, as the time increases by 1 second, the height increases by 2, and then it goes down 1, and then it does not go down at a constant rate. It goes down 2, and then it goes up 1, and then down 1, and then down 2. So it's just all over the place. And as you guys can see here, it does not make a straight line, so those would not be linear functions. So again, do the slope test if it's a table. You know, they each have to increase and decrease at the same, and then if on a graph, it's very obvious to see if it's a line or not. Okay, so this would not be linear because that makes a U, not a line. That middle, yes, it would be linear. This last one here, sorry. Yes, this is actually two straight lines. So this is not a constant rate of change. We have an increasing slope and then a decreasing slope. So that's not a straight line. That is not linear. And then again, you guys can see here, the only one that would be linear would be number 3 because the other ones do not make straight lines. Why does that keep doing that? There we go. Okay. So do the tables represent linear functions? This is where this is less visual, and this is where we need to see, look at our tables. So let's look at option A. First, let's look at our outputs. From -8 to -16 would be down 8. -16 and -24 would be down 8. -24 to -2 would be down 8. -32 to -40 would be down 8. So so we know our top of our slope is going to be -8 if it is. And then these all increase by 1. And then, so this would be a linear function. It has a slope of -8. So yes, and then m, or the slope, is -8. Here we have let's look at the output first. 1.5 to 2.5 is +1. 2.5 to 5.5 is +3. 5.5 to 8.5 is +3. 8.5 to 10.5 is +2. So that's all over the place. That is not. It's what represents nonlinear. So this would be no. That's linear. This is nonlinear. Sorry, I need to read the questions more carefully. So B would be nonlinear because the outputs are not at a steady rate. We have up 1, up 3, up 3, up 2. No, that's all over the place. Can't happen. All right, let's look at option C. We have +2. 3 to 7. I can already see one's +2 and then the next is +3. This is not linear. So B and C are nonlinear because the outputs do not increase at the same rate. All right, does this table represent linear or nonlinear? So let's take a look. From 5 to 6 is +1. From 6 to 9, already not linear. +1, +3, no. Non-linear. Fake news, not linear. Okay. Let's keep going. All right, suppose 20 rabbits on an island, triple every 6 months. Make a value of tables where to show where it would be after 2 years. Does it represent a linear or non-linear? And we're not going to worry about part C right now. So 6 months is a half a year. So we're going to increase by a half on these. So this is +1/2. Because again, 6 months is half a year. So you start with 20. After half a year, multiply that by 3, you get 60. And then after a year, you have 60. Multiply that by 3, you get 180. So first I'm increasing by 60. From 20 to 60, which is plus 40. Then I'm increasing from 60 to 180, which is plus 120. So this is going to be nonlinear because it's not increasing at a steady rate. It increased by 40 and then 120. So that does not work. All right. And we're not going to worry about that last part right now. All right. And I believe this is, last but not least, the same thing as about brown bats in Missouri. Is it linear or nonlinear? And it's nonlinear because the rate of change is not constant. It goes down 6,900 and then up 1,000, then down 4. No. Not linear, fake news, not happening. And this one we could make predictions because it's increasing. Well, it's not at a steady rate. Like, we still have a pattern. It's still times 3 each time, so we could keep that table going. But here, there is no rhyme or reason to anything, so we cannot make predictions with that. All right, quicker video today. So now you guys are going to head to the Pearson and work it out, and I will see you on Zoom at 10. Bye, I miss you.